Hey guys, in this session we're going to be looking at the 2014 Level 1 Geometric Reasoning exam paper. As always, the best way to watch this video would be to pause at the start of the question, have a go at the question by yourself, read it, and then try and work out the answer, and then actually watch the video and see how I did the answers. Okay, so let's get started. So with this first question here, you've got a wall has been tiled with square tiles. Each tile measures 12 by 12. So we've got 12 by 12. Some of the tiles have been cut diagonally as shown on the right. What's the length of the cut side AC? So basically they're asking you, what is this side here? And you have a right angle triangle there. So you could have AC squared equals 12. Let's just do that. So remember that hypotenuse squared equals the two sides squared. So in this scenario, we have AC squared equals 12 squared plus 12 squared. So AC is going to equal square root of 288, which then equals 16.97 centimeters. So correctly calculates length is what's going to get you an achieved grade for this particular question. Okay, the next one. Okay, so for this question here, you've been asked to describe the triangle ABC using geometric terms. Okay, so with ABC, we are looking at this triangle here. We know it's right angle, and we also know that it's 12 centimeters on both sides there. So basically, this triangle is isosceles and a right angle triangle. And that's basically what you need to do in terms of writing this using geometric terms. You kind of need both, guys, here. You need to actually say isosceles and you need to say that it's a right angle triangle to get an achieved grade. Okay, next question. Okay, so with this question, they've attached basically that the diagonal that they cut through in the previous question, they've attached it. So remember in the previous question, this was you had AC going like this. So all they've done is they've cut this and they've actually attached this to the top. So the question is, how high is H? So there's a couple of ways you can actually do this. The first method, actually there's a few ways you can do this. The first method is knowing that if I look at this triangle here, from part A, we know that this was 16.97 centimeters. This was 12 centimeters and 12 centimeters. So what you could have done is you could have created a right angle triangle like this, where the distance from the base here would be half of 16.97. And then you have 12, and then you can use 12 squared minus half of 16.97. So that's one way of doing it. The other way you could have done it is, because this is 45 degrees, and you're trying to figure out what height is, that's 12. So you could actually use trigonometry for that. So where this is hypotenuse, you're trying to figure out opposite. So you're using sine rule. And so in this case, you would have sine 45 equals opposite over hypotenuse. Sine 45 equals, now the opposite side is the same as h. So I'm just going to put that as little h, and the hypotenuse in this case is 12. So little h is 12 times sine 45. Now in this method here, to figure out h, you can write it as h squared is equal to the hypotenuse, which is 12 squared, minus half of 16.97. So half of 16.97, what do we have? Is 8.485. And you should, when you do this, you should get h as 8.485 as well. Now you might wonder why I'm getting the same as this, because remember that these are isosceles triangles. So it's 45 degrees and 45 degrees. So that's another way you could have done it. So half of 16.97 is 8.485, which means H is also going to be 8.485. Okay, so basically that's what you need to have done for this question. So in terms of getting, you have to show at least one step towards your answer. So either you're using your hypotenuse or using trigonometry. So if you show it with one step, then you get a merit. Answer only, all right, answer only is going to get you an achieved. Okay, next question, folks. Okay, so with this question, you've been asked, basically they're cutting a new triangle. All right, so the new triangle where they've actually given you what XY is. Now remember, in the first part of this question when we did it, this here was 16.97, but now they're telling you that XY is actually 12 centimeters. Okay, and you're asked to find out what the new height is going to be. So the distance from these 2 points is 12 centimeters. Now you kind of can do the same thing as we did in the previous question, but like I said, you know that this is going to be 45 degrees because this is 90 degrees and it's an isosceles triangle there that you're dealing with, so that's going to be 45 and 45. What you could do is you could halve this, and when you halve this, you're going to end up with 6 centimeters here, and that being 45 degrees. All right, and because that's being 45 degrees, you can kind of see that you're creating an isosceles triangle. So if you create an isosceles triangle, then H is also going to be 6 centimeters. So yeah, that's one way of doing this. The other way you could have done is you could have actually used similar triangles. So from using the previous question, but I think that's doing a lot more work. The more simplistic version is actually recognizing that you're actually dealing with a isosceles triangle. So in this, I would probably just explain it a bit more, just to say that because X, B, Y is isosceles triangle, and then dividing 12 by 2, so then I say xy divided by 2 equals to 6. Then if you want, you could actually put another point here. I'm just going to call this M maybe, and I can say that and I can actually say, because xby is isosceles triangle, BM or H is equal to 6 centimeters, because you're creating another isosceles triangle. Okay, so that's going to get you a merit. Now if your working is not clear but the correct height is given, then you get an achieved. All right, next question. All right guys, so for this question, I'd actually ask you to pause somewhere, read through the question, and then see what answer I've actually got. Okay, so in this question, you've been asked to calculate the size of angle X in diagram 1. Now, your diagram 1 is here, angle X is right there. So let's just look at that little orange triangle. If we have a look at the orange triangle, we have X here. Now, the base, which is all the way from here to here, is going to be 8 centimeters. So that could be written as 8 centimeters, and then the height, which is here, which is going to be 3 centimeters. And of course, this is a right angle triangle. So you're trying to figure out the angle. You have opposite, you have adjacent, so you're going to use tan of X is equal to opposite over hypotenuse. So then this could be written as tan X equals 3 over 8. So X is equal to inverse tan of 3 over 8, which should give you 20.56 degrees. This is worth an achieved. Also make sure your calculator is in degrees. If it is in radians, you're going to get a different answer. All right, so we go to the next question. So for the second part of this question, you've been asked to calculate the size of angle Y, and that's here. So the first thing you kind of need to do is split up that yellow triangle. Okay, so if we have a look at this yellow triangle, it's going to look like this at the moment, where your Y is here. We know that this is 5 centimeters, this is 3 centimeters. So what we could do is we could actually see that if this is 3 centimeters, then the distance from here to here is going to be 2 centimeters. And now you got to work out what that height is going to be. Now to figure that out, you got to look at these two values here. So see how from here to here is 8 centimeters. From here to here is 3 centimeters, which means from here to here has to be 5 centimeters. So you can put that as 5 centimeters. So your triangle is going to look like this, where you have Y, you have that is 2, that is 5. Basically, you are doing exactly as you did in the previous question, which is tan of Y equals opposite over hypotenuse. Tan of Y equals 5 over 2. Y is equal to inverse tan of 5 over 2. So in this case, Y is equal to 68.2 degrees. And this question was actually worth a merit. All right, next part of this question. There's no achieved grade for this question, guys. It just goes straight into merit. Okay. All right, next question. Okay, so with this question, you kind of have to use your two angles that you calculated in the previous question. All right. The reason is they're saying they rearranged this, and then they're asking you this question of explain why the area seems to have changed. All right, so what you want to do is the first thing is you've figured out what x is. Now x was 20.56 from the first part of this question, so that's what x is. Then you figured out what y is. Y you figured out as 68.2 degrees. So, and if you notice, that's going to be y. So for starters, if you're going to have a rectangle, the corner should be 90 degrees. So x plus y should equal to 90 degrees if shape is rectangle. Okay, now x is equal to 20.56 plus 68.2. It actually equals to 88.76 degrees. Now this is not equal to 90 degrees, so therefore not a right angle triangle, not a right angle triangle. And so that means, so you can't multiply base times height to get your area. Okay, so in terms of grades, excellence for the whole package. If you just identify this, that it's the left hand corner is not 90 degrees, then it will be a merit. There's no achieved grade, looks like that's actually attached to this question, folks. So that's basically it for this question. Okay, so let's go to question number 2. Okay, so question number 2, you've got a cyclic quadrilateral. It says calculate the angle M in the diagram below. Now this should be one of the easiest achieves you should get, because M is equal to 84 degrees. The reason you get 84 is because M is equal to 180 take away 96. So we have angles on a line which equals to 180 degrees. Okay, so nice and easy achieve to start the question with. All right, let's go to the next one. Next one, they're asking you for angle J in the diagram above. So what do we have? So the first thing we know is, we know that M equals to 84. I don't think that's going to make a huge difference in this case. But what we do know is that this is a cyclic quadrilateral. Now, because it's a cyclic quadrilateral, the opposite angles are going to add to 180 degrees. So that means you've got 96 and N should add to 180 degrees. So you can write it N plus 96 equals 180 degrees because they are opposite angles in a cyclic quadrilateral. Rearranging this, we're going to get n equals 180 minus 96, which is going to give you 84. So we've got n as 84. The next thing you can do is to work out j is you create a triangle. Okay, so then we can actually say j equals 180, take away 41, take away 84, because they are angles in a triangle. Okay, so simplifying this, you should get 55 degrees. So to get a merit for this question, yes, this is worth a merit. You need the answers, correct answer for j with valid geometric reasoning stated, correct answer for angle j, or one step with reason. So you will get an achieved if you just give the answer without the reason. Okay, next question, folks. All right, so with this question, you've been asked to find the size of angle P. So the first thing to look at would be actually work out what R is, because you've got a parallel line. See how you got a parallel line going this way, and so you've got 32 here, which means R is also equal to 32. So that's the first thing I'm going to do. I'm going to put down R equals to 32 because they are alternate angles in a set of parallel lines. Okay, so that is 32 degrees. Once that's 32, I can see that these two lines here make this triangle an isosceles triangle. So what I can then do is I can actually say I can say P equals to Q because it's an isosceles triangle. Then I can actually say that means P plus 32 equals 180 degrees because they are angles in a triangle. So I've got 2P plus 32 equals 180 right here. 2P equals 180 take away 32, so 2P equals 148 and P equals 74 degrees. Okay, so grades, merit for the final answer with these two reasons here, or three reasons. All right, if you have just answer only, then you're just the answer. If you just put P equals 74, then correct answer for P, yep, just the answer only will get you an achieved. All right, let's go to the next question. Now what's interesting about this next question is it is exactly the same question as the previous one. The only difference is you've got a W instead of 32. All right, so if you actually got the answer for the previous question, then just write everything in the same way as it is, and you should be able to get, like, I mean, what I'm saying is, like, use the same geometric reasons from the previous question. All right, so what you have first off is, well, we know that these two are parallel lines, and because they're parallel lines, we can say that R equals to W because they are alternate angles in parallel lines. All right, now we still have that same problem of P and Q being the same, so we can still say P and Q, they're the same because they're angles in isosceles triangle angles. So at this point, then you can say P plus W equals 180 degrees because that is angles in a triangle. So what you then have is you've got 2P plus W equals 180 degrees. So then you can say 2P equals 180 minus W, and P equals 180 minus W divided by 2. So guys, correct answer for P with those valid reasoning is going to get you a merit. If you just give an answer like this, you are going to get an achieved. Cool, that's it for this question. We go to the next one. All right guys, so with this question, you are asked to prove why these triangles ABC and EBD are similar. Now, the first thing I'm going to do is I'm going to do something really cheeky here. I'm going to put this as little c. I'm going to put this as little a, little d, little e, and maybe this angle here, I could put it as b. Now, if this is b, this is also going to be b because they are vertically opposite angles. All right. So, I mean, the reason I'm using I could use the small letters, but I could also use it with the bigger ones, but you guys will understand what I'm trying to do here. So the first thing is I could say angle C equals angle D. All right. So when I say angle C equals D, I'm looking at angle ACB equals ADE. And the reason these two angles are equal is because they are angles on same arc. Okay, so this is, I'm looking at angle C and D. See how this part here, they're on the same arc, those two angles. Now the next part I'm going to say is angle A equals angle E. Now this is, I'm looking at CAB equals D or BED. All right, and they are also angles on same arc, but the arc that I'm looking at is actually this one here. All right, that's the arc I'm looking at for those two angles. And of course, I've also said that angle B, and you know how I showed you that two B's are the same? Well, there are two B's because I could actually say that I'm looking at these two angles here. Actually, wait, let's use this color here. So that's angle CBA equals DBE because they are vertically opposite angles. Now, once I've basically proved that that angles in CBA equals angles in BDE. Therefore, it is similar triangles. So, grades wise, do this fully and you're looking at an excellence. If you do like minor mistakes here and there in your proof, then you're looking at a merit. Okay, that's basically this question, guys. We'll go to the next one. All right, so this question, it's a follow-on from the previous question. Okay, so because it's a follow-on from previous question, we've already done all the hard work. So we've actually proved that this two angles here are the same. We've proved that this and this is the same angle, and we've also proved that we have these two angles are the same. Okay, now the question is actually saying prove that AB times BD equals BC times BE. So just need to look at what I'm going to be working with. AB is here, so that's AB. BD is here, and then BC is here, and BE is here. Okay, now remember with similar triangles, you could go one side, like you kind of just match up the sides, right? So what I could do is, if I do this side divided by this side, it should equal to this one divided by that one. So what I'm going to do is I'm going to put AB divided by BE equals BC divided by BD. Okay, that's what you do for similar triangles. I mean, you can do it in other ratios as well, but I'm going to do it in this way. Once you have this, just cross multiply. Okay, when you cross multiply, you get AB times BD equals BC times BE. And you're done, because that's what the proof is saying. Excellence. There's no other grades for this question apart from excellence, guys, according to the marking schedule. So, yeah, seems fairly simple, doesn't it? All right, let's go to the next question. I believe that's the end of question 2. We go to question 3 now. Okay, so question number 3. We got somebody using a protractor to measure the angles. He's made a mistake in measuring the angles. The diagram is below is to scale. Diagram below is to scale, which means it's actually done correctly. Now it says there are 2 geometric reasons that show Ahmed must have made a mistake. Explain what these 2 reasons are. Now the first reason you can look at is this one right here. If it's drawn to scale, you can't have 70 degrees like that, because this is an obtuse angle. All right, an obtuse angle is bigger than 90 degrees. Now, you know, this doesn't make sense, because remember, 90 degrees is going to be here like that. So that's his first mistake. First mistake is 70 degrees is incorrect. And what's the second mistake? The second mistake is, you know, he's got a 4-sided shape. So the 4-sided shape angle must add to 360. All right, and in this case we got 70 plus 90 plus 87 plus 73, and that actually equals to 320. So that's the second mistake that he's done. Okay, so merit for 2 reasons. Okay, achieved if you get one of the reasons correct. And there are other ways of doing this as well, but I'm just going to keep the real simple one here, folks. So the next part of this question is kind of connected. So the next part says he used his protractor to measure the angles in quadrilateral. He's made a mistake. Yeah, so we know that. Explain what mistake Ahmed might have made in using his protractor. So if you kind of have a look at this, the last time when we added the angles inside, right? The 4 angles added up to 320 degrees. But it really should be adding to 360 degrees. So I guess the mistake he could have made, and I guess this is kind of a tricky question, but you know, with a protractor, he might have actually used it the wrong way, because you know how this is 70 degrees, which means that could be 110 degrees. All right, because if he has put it the wrong way, then if you have 110, now 110 plus 87 plus 73 plus 90 is actually equal to 360 degrees. So really used the wrong side of protractor is probably the answer we're looking for here. And what is it worth, this question? Just an achieved. Okay, we go to the next question. All right, guys, so for this particular question, I would actually, you know, you really got to pause. You got to read through the whole thing and then answer the question. So pause here. Okay, I'm assuming you've actually read through the whole question at this point. So basically, they are saying in this question that you've got a tessellation that's happening. Now, for those of you that are not familiar with tessellation, it's basically just taking one image and repeating itself, like flipping it upside down and then kind of joining them up together. So in this case, you've got this little blue shape that you start with. All right, it's actually flipped upside down to create this gray shape, and then the blue shape actually comes back here, and you can see the pattern kind of repeating itself. So that's what's happening. So what they're asking you for this question is, why is it true that any quadrilateral will tessellate? And they've given you a diagram, which I'm going to show in the next question. So this is the graph this is the diagram that's been given to us. and it's got all the labels that are done. So, so it kind of makes it a bit easier to work with. Now, the first point that you need to look at is, like, if you look at the center of this particular point, center of this little diagram, you've actually got 4 angles surrounding it. Okay, so the 4 angles in this case are Q, U, and A, and D. All right, that's the first thing. Now, the second thing is that for you to actually have a tessellation that actually works, all right, for a tessellation to work, you've got to kind of repeat this pattern where this pattern has to repeat itself, right? So what we've done is, and I think this is a good point to actually go back and look at the previous diagram just to make a bit of sense. I'll actually show you guys how this looks like. So the long end doesn't actually change, it kind of just sticks to itself. So it looks like this. So what you then have is you've got angle A here, you've got angle D there, that's going to be U, and then that's going to be Q. Okay, now the next part of this is, because you've got, like, it kind of matches up, see, these 2 points match up. So the next one, it's going to look like this. I'm going to try and draw this perfectly, but I might get this wrong. Yeah, that is terrible. Let's try that again. So where this is going to be U, this is going to be Q, that's D, and then that's, what's that going to be? A. Okay. And now the black triangle that I draw on the left-hand side is going to kind of pop over here like this, where this is U, and that is going to be A, that's going to be Q, and that's going to be D. So from this, what you can actually see is, for this to tessellate, all right, for this to tessellate, angles meeting at the point, angles at point should equal 360 degrees, so that there's no gaps. So the third point is, you can see that Q plus U plus A plus D equals 360. Now, the reason it equals 360 is because you're working with a quadrilateral, and quadrilateral, the angles always add up to 360. Okay, so finally, based on that, we can say that this quadrilateral, always have problems, will actually tessellate. All right, so just using a bit of your geometric reasoning and just working around it. So in terms of grades, excellence, if you get all 4 points correct. If you get one of them correct, you get it achieved. And if you make a reference between quadrilateral and 360 degrees at a point, then you're looking at a merit. Okay, that's it for this question. We go to the next one. Okay, so in this question, you've got, he's drawn a pentagon. He draws the exterior angles, which are shown in the dotted line. He works out this angle of C as shown below. Give the geometric reason for his calculation. Well, all you have to do in this case is basically just say sum of exterior angles in a polygon of any polygon is 360 degrees, and that's it. You're done. Nice and simple, achieved. Tick there. Okay, let's go to the next part of this question. All right, so for this part of the question, it's actually asking you, why is C negative 106? Negative 106. And I guess you kind of have to look at how you actually going about it. So what I'm going to do is I'm going to start here, right? So I'm starting here and I'm trying to work out my exterior angle. So in this, I'm actually going anti-clockwise. I come to this point here, I am going anti-clockwise. All right. In fact, I look at this point here. I'm actually going anti-clockwise. Come here to this point and I'm going anti-clockwise. However, when I get to this point, I'm not going anti-clockwise. I'm actually going clockwise. All right, because I'm going clockwise, this is because my first point is one of the exterior angles is pointing inwards, and so that's my first point. And my second point is it's negative. It is negative because the rotation is clockwise in this situation. Compared, because when I compare it to the other parts, right, compared to anti-clockwise with the other exterior angles. Now, the reason why I need to mention that anti-clockwise part is because, see, I could have actually done this as well. So I could have actually started from this point here and first off go this way, but and I'm just giving this as an example, guys. I could work backwards as well, but it's not going to work in this because just ignore that last part. I don't want to confuse you. All right, let's just stick to this. But you got to mention the clockwise and the anti-clockwise part because that's what's going to make the angle negative. Okay, so grades wise, negative measurement due to change in rotation or direction, you're looking at an excellence, or recognizing that one of the angles is inside, it actually gives merit. So merit is like giving one of these two reasoning. Excellence is when you give both of them. Cool, let's go to the next one. All right, guys, so in this pentagon, we got angle EGR. Where is EGR? Oh, EGR is here. Okay, EGR and GRA. GRA is this angle here. They add up to 180 degrees. How does this prove that lines GE and RA are parallel? Okay, so the one thing you need to know is if EGR and we add it up to GRA, and if that equals 180 degrees, then they are co-interior angles. And because they're co-interior angles, because remember co-interior angles add to 180, therefore RA and GE must be parallel. Yeah, that's basically it. These two have to be parallel because those two angles add up to 180 degrees. And remember, co-interior angles add up to 180 degrees. So doing this, you're looking at a merit. Just stating the co-interior angles add up to 180 is state co-interior angles on parallel lines rule. If you just state the rule, it's just an achieve. But if you actually prove it, because it's 180 degrees, it's a merit. Okay, let's go to the next question. Okay, so with this question, you're asked to find out what angle APE is, or actually it's asking you to prove that APE is PAR plus PEG. So first step is, what I'm going to do is I'm going to add a line. Add a line parallel to RA and through P. So what I should have is I've got a line that looks like this. So basically I've got these three lines are parallel. Okay, now I'm trying to figure out what angle APE is. Angle APE is that one there. and I'm trying to prove that it's PAR plus PEG. Now PAR is this angle here. Okay, so what I could do then is I'm gonna create, because it's angle PAR, then I'm gonna create another point here, folks. I'm gonna put this as point Q. Okay, the reason I'm doing that is because I can see that angle PAR is the same as angle APQ. So what I could say is angle PAR equals angle APQ, and that's because they are alternate angles on parallel lines. And I pretty much do the same thing for the one below as well. So I could do PEG is going to be the same as EPQ. So I have angle PEG equals angle EPQ. And once again, that's because they are alternate angles on parallel lines. And now I could actually see that this orange is going to be angle PAR, and then the yellow part is going to be angle PEG. And so with that, I can actually say, therefore, angle APE equals angle PAR plus angle PEG. So basically, complete clear proof with geometrical reasoning is going to get you an excellence. But if you kind of do a half job, you give the correct reasoning but don't really fully do it, looks like you could end up with a merit even if you give some of the proofs and some sort of clarity. You need to get a merit. Okay, so that's basically it for this paper, guys. As usual, thank you for watching. If you have any questions, pop it in the comments below and I'll try my best to answer them. Remember to keep your graphics calculator mode in degrees, and also if you can't remember the reasons, just write the reasons in full if you can't remember the little symbols or the short form of writing it. All right, that's it from me. Thank you for watching and good luck.